Welcome to another Tech Talk session. So today I will talk about gRPC over REST. So we'll see the overview. So here is my overview for today's session. So first I will give some introduction about REST and RPC. That's a quick note. And then after that I'll give some history and introduction to today's topic, which is gRPC. And as the third phase, so we'll discuss about the properties of this gRPC. And so as the fourth step, so I will demonstrate how to use gRPC. And last but not least, so we'll discuss about the benefits of gRPC. So let's move on. So REST, what we all know and have heard. So REST is representational state transfer. So so here is a very brief quick note on REST. So the most important thing is REST is an architectural pattern. So and it has a uniform interface. So that means we write the endpoint. So we have we develop some API interfaces so to access the resources. So then the consumers can access those API interface and get the resources they want. And also the other thing is REST is stateless. So which means so although the client requests, so the server does not store anything related to the client's request. So it is the responsibility of the client to maintain uh, if they want any state to be maintained. So and the other thing is REST is cacheable. So which means so the resources we get from the server side can be cacheable. So the other important thing is it is a client server based one. So which means so the client and the server is independent of each other. So that means client only knows uh, how to access the server endpoint. So it only know the URIs to the necessary resources it want. So that's a brief introduction on REST. So we'll move on to the next topic, which is RPC. So it is called, the long term is remote procedure call. So we'll see what is it. So this is the description I gathered from the Wikipedia. Uh, this is about the remote procedure call. So this actually means, so like we are invoking a function which is in a different address space. So maybe in a different machine. So we invoke remote calls, but not like REST. So in REST we have to make HTTP calls, but in here it's like the client calls a local call, but in the back of this stage, the function calls to a remote server. So this is a brief introduction about the RPC. So we'll see what happens in RPC. So actually I included this introduction so as to understand about it will be easier to understand gRPC if you know what happens in RPC. So this is the procedure what happens in a basic RPC call. So in here, actually we define some services. So services specifying the methods and parameters and their return types. So that interface, service interface, is the implementation for those service methods is done in the server side, and for the client also we have in the client stub, we the client stub also provides the service methods. So like if the client wants to access a server method, so it directly calls this client stub. So it feels like this is like a local call, but then the client stub makes the connection over the network and then calls the server machine, and the server stub makes the the necessary server call and then gets the response. So then again, the server stub package all the messages that needs to be sent to the client, and then it sends over the network, and likewise the process happens. So let's move to the gRPC, which is today's topic. So we'll see what does then gRPC means. So here in this term, what does G stands for? Actually, if we go to this link below, you can find a number of terms that this G stands for. So I have included some of them. So G can be stand for gRPC itself, good, green, likewise many terms. So the reason is for each and every gRP release, so they provide a term for G. So that's about that. And yeah, this is the basic idea. So this is like a summary. So gRPC is a high performance open source universal RPC framework. So this is like a best of breed of RPC protocol, so which is a modernized version with high performance and with high speed of transmission. So this is some kind of best of breed product. So let's see some history about this gRPC. So as I said, this is open source remote procedure call. So, and this is also considered as the gRPC is this latest framework from the RPC protocol. And this has been developed at Google in 2015. So before that, actually Google has used an RPC system called Stubby, and so then it has been converted to this gRPC. So those the team members has made this Stubby into an open source project with based on the public standards and making it a good RPC system. So that's like how this gRPC has born in 2015. So and this is now owned by the Cloud Native Computing Foundation. So that's a brief introduction about the history. So let's see what are the gRPC goals. So these are the three main goals of gRPC. So as I said, so this has been developed so as to increase the performance and to make scalable RPC frameworks, RPC systems, and to make efficient systems, and also for the developers to use easily, and also for to use in microservices. So this with gRPC, developers can build microservice based applications using gRPC. So let's move on. So these are the gRPC properties. So I'll start off with one by one each. So the most important property is gRPC uses protocol buffers. So these protocol buffers are used as interface definition language. So when defining the services. So let's see how this happens. So as I said, so the default data format used by the gRPC framework is protocol buffers. So in gRPC, they use the protocol buffers. We use protocol buffers for serialization of messages and also for the communication over the network. In REST, usually we use JSON, but in gRPC, these protocol buffers are used. So these protocol buffers are actually, it's a method of serializing data. So we can use this serialized data to be stored in files, or even can be transmitted over the wire. So since these actually this can be actually encoded to binary format. So because of that, not like JSON actually it has the text context. So but in protocol buffers, this can be encoded to binary. So because of that less size needs, so this increases the transmission speed. So we'll see how to use these protocol buffers. So actually, use when using protocol buffers, what we need to do is, the data that needs to be serialized are included in a configuration file. These files are called proto files. So these files has a .proto extension. So after that we write after that we create this proto file. So we compile with the proto compiler to get the uh, serialized versions. So here is a difference between the protocol buffers and JSON. So as you can see, the JSON has the content also included here. The data and context are not separated. And in protocol buffers, so we define as this. These are defined as message formats actually. So I will show them in the next slide. So we have the data type, and we then define the field name, and then a field identifier. So this 1 and 2 is actually not related to the value of these fields. So this is actually a normal uh, field identifier. So moving on. So here I have included a sample proto file, how it looks like. So as you can see in the top of this proto file, so there is this field. So we write the syntax as proto3, since this proto3 means the current version of the protocol buffer. And you can see now, we have a structure like with message keyword. So we can, so as in JSON we write user object, so we can have those instead of person likewise, so with the message keyword. So as in most of the time, so we define the data type and the field identifier, and then the field name and the field identifier. So likewise, so the protocol buffers also support various types of data types, enum, bool, string likewise. And also you can see at the bottom, so repeated phone number. So this means like a list of phone numbers. So for the repeated, so that's highlighted by the repeated keyword. So moving on to the next property of this gRPC. So this client and server code can be generated from the service definition for like more than 10 languages. So which means, so we define the services in one proto file, and after we compile that proto file, we can generate client and server code. So since this protocol buffers supports uh, a, a large number of languages, so we can have uh, different client and server codes in different languages. So here are some of the gRPC supported languages. So you can see most of the popular languages are supported. Uh, so here is the sample diagram of how gRPC server works. So as you can see, we have a gRPC server that's implemented in C++, and there are two clients implemented in Ruby language and in Android Java. So, so we can have any number of clients. As you can see, we can have clients with any of these languages, and we can have servers with any of these languages. So what the client do is, so with its stub, it calls the gRPC server. So it actually sends a protocol buffer request, and then the gRPC server responds with a proto response, sensor response. So likewise, so this is the basic structure of gRPC. So the special things are like this gRPC uses protocol buffers and can have a large number of uh, clients with different languages. So the other main property is actually, so this gRPC is built on top of HTTP2. So in earlier tech talk, Hiran also described about these benefits of HTTP2. So because of the use of HTTP2, it supports multiple connection options. It's like Unary server-side streaming, client-side streaming, and especially the bidirectional streaming is supported. So unlike in HTTP1, when we make multiple requests, so so in HTTP1, so they are served one by one, so that makes the systems slow down. So but in HTTP2, it allows multiplexing, so the multiple requests and responses can be served at the same time in one TCP call. So that's the special thing of using HTTP2. uh, in gRPC also, it renders some advantages. So here is the multiple connections supported in the gRPC. So as you can see, in the first one, it is the basic request response model. So the client request with a single sends a single request and get back a single response. So in the right side, you can see server streaming. So what happens in server streaming is, so the client sends a single request and the server responds with a stream of messages to the client. So after sending all of the messages, the server uh, the server completes its processing, and when the client completes when the client receives all of the messages from the server, so the client completes its actions. So in the client streaming, it's the other side of the server streaming. So the client sends a stream of requests to the server, and the server responds with a single sends a single response to the client. So the fourth RPC connection supported in gRPC is the bidirectional streaming. So what happens here is both the client and server can send streams of messages to each other, but and so these streams are actually independent. So the client and server can write and read messages in any order. So uh, like in ping pong order, so where the client sends a message and server responds for that message, likewise. So it can has it doesn't need to have any order, it depends on the application. So let's move to the demonstration. So I'll demonstrate with some steps. So I will demonstrate how to use gRPC for a very simple banking service. So first I will create a proto file as I described earlier. So the proto file is bank service proto, and then with that proto file, I'll generate the client and server stubs, and then so we have to have a server to start uh, the resources. So we need to create a server for that. So I will create a bank server, and to get the services, we need to create a bank client. So I'll demonstrate that. So as you can see, can you see the screen?
Yes, we can.
Okay, thank you. So here is the gRPC site. So you can get any details from refer any documents here. So it actually gives codes for the different supply codes for the different languages, also how to use them. So you can see the codes that they support for these languages. So for the demonstration, I will do use in Python language. So here is the documentation they have provided for us. So first thing is we have to upgrade the pipe, and we have to execute these commands, and then need to install gRPC. So we have to execute this command, gRPC IO command, and then we have to, next thing is we have to execute this uh, command to get the gRPC tools. So with these tools, it has the proto compiler and also the plugin that needs for the Python. So actually I have installed all of these three. So I will start uh, after that. So I'll create a folder, and I'll demo. So here is my Python project. So I don't have anything here. So what I'm going to do is, so first, as I said, first we have to write the proto file. So I have earlier created a proto file. So which is, I'm going to copy here. So this is the proto file I created for the bank service. So as I said, first we have to write the syntax that we are using the Proto 3 protocol buffer version. And I have written the bank service details. So in the bank service, I have created a method which is named create account. So it is a remote procedure call. Create account is its name, and it takes a request. So the request parameter is a user. So user is a message. So these are in protocol buffer syntaxes. So and then it returns account message. So the response is a type of account. So actually this is a normal unary connection. So you can see I have commented out this. So this is this one is actually for the server streaming. So you can so in server streaming, the client sends one request, and the server responds with a stream of responses, messages. So for that, so in the response parameter, we have to give the stream keyword. So opposite is the client streaming, where the client sends a stream of messages. So for that, in the client side parameter, client side request, we have to put this stream keyword there. And in the bidirectional streaming, so the stream keyword has to be in the both sides, in the request and response. So you can see this is a message. This is the user. So it is structured as a message. So we have the name field is of a string data type and its identifier. Likewise, you can define as it want in the bank service. So the next thing is next step is we have to generate the client and server stubs from this proto file. So what I'm going to do is so I have listed down the instructions here that needs to be done. So I'll execute this command. So what this command do is, so it takes our proto file as the argument and it outputs two files after compiling and after compiling into a Python file. So it generates two Python files. So we'll compile them. So as you can see, so two files were created. So this file is actually it includes the messages, the descriptions that is relevant to the proto file. So and actually this class does not include any gRPC specific uh, related information. So the gRPC related information is included in this second file. So this file actually imports the first file. The important file is this. So where this supports the stub class, and also it has a class for the servicer. So you can see here I have this create account which I defined in the inside this bank service. So which means, so this is like a interface from the methods I gave in the bank service. So there is another function, so which is this. So what this does is, so it takes a servicer. The servicer means actually in the server we have to implement this bank service servicer, and then that class is actually sent as this argument. So which what so from this, so this service is added to the gRPC server. So that's it. So I'll then need to create the bank server. So I'll copy the bank server and bank client codes which I have created earlier. So here is the bank server class. So as you can see, so what I have done is I have so this is like a subclass of this bank service servicer, which was this class. So we have to implement these methods in our server. So I have implemented this create account, and I'm going to return account as in here. So I have given the field names that is in the account message, and that's a simple function only. So I'm going to start this server now. So I can start this server with its name like this. So now you can see the server is starting. So next thing is we have to run the client. So this is my client code. So what this has to be done is, so we have to create a channel for the connection. So and likewise, so I have uh, listened to this port as a channel, the server's port as a channel, and I am going to create. So here I have created object from the client stub. So here, so this is the client stub. So with that channel, I have created a client stub to call for the methods. So after that, with that stub, I have called the create account, so which is in the remote server, and I have uh, added the request parameters, which is related to the user. So after that, so I have print the uh, response details. So let's run. So when running, you can see, so since the server is started now, so all the response details are printed as this. So that's how we can use gRPC for client and server communication. So in the demonstration, I actually used only Python as the client and both the client and server. So it can be different for client and server. It can have different languages. So that's about the demonstration. So I'll continue my presentation. So those were the steps. So let's see what are the benefits of gRPC. So the gRPC, as said in the goals, as I said in the goals section also. So this is great for the microservices because gRPC is efficient, and this is good for point-to-point real-time communication because this supports bidirectional streaming, as I said. So we can have like a ping pong communication. So like for chat applications, this gRPC is good. And the other thing is this is good for when we have multiple language environments. So since gRPC tools, the proto buffer tool supports popular languages, so we can use gRPC for multi-language environments. And also in places where network bandwidth are limited, so we can use gRPC. So because these messages are lightweight message format, uh, these messages are actually serialized to a lightweight message format because by using the proto buffers. So these were the benefits of these are the benefits of gRPC. So with that, I'll conclude my presentation. So thank you.